The next topic is series. As the chapter name is sequence and series, first of all we describe about sequence. Now what is series? Series is formed of sequence. So sequence is the base of series. Let A1, A2, A3 and so on be a given sequence. And if we form a new sequence of terms A1, A1 plus A2, A1 plus A2 plus A3, so on, then this new sequence is called series. And in this series, if we denote the Sn as we take in the sequence Tn, so in this series, as it is sum series, so it is denoted by S. So it is a sum of terms. So if we see in this, Sn denotes the sum of first n terms of the given sequence. So the sequence A1, A2, so on becomes S1, S2, S3, a new sequence Sn. The series corresponding to given sequence. Hence, every series is a sequence and any term of the series is sum of first n terms of its corresponding sequence. Let us take sequence of odd numbers such that 1, 3, 5, 7, 9 and so on. So here S1 is A1, that is 1, S2 is A1 plus A2, that is 1 plus 3 is equal to 4, and S3 is A1 plus A2 plus A3, that is 1 plus 3 plus 5, that is 9, and if we see S4, that is A1 plus A2 plus A3 plus A4, that is 1 plus 3 plus 5 plus 7, that is 16. And so as we move down, Sn will be sum of n terms, that will be A1 plus A2 plus so on An, that is 1 plus 3 plus 5 plus 7 plus up to 2n minus 1, that is the nth term of the sequence. Then we get 1, 4, 9, 16, so on. That is 1, 2 square, 3 square, 4 square, so on. Therefore, Sn will be n square. That is the series derived from the sequence whose nth term is 2n plus 1 or 2n minus 1. So, this is the way to derive a series from a sequence. Now, as we learned in previous lecture, how can we find a series when we know about the sequence? Now, we will learn in this lecture how can we derive the formula for an when Sn is given. Now here we will learn how can we find an when series is given. So as we know that let S1 is equal to A1, S2 is A1 plus A2, or we can write S1 plus A2, and S3 is A1 plus A2 plus A3, that is S2 plus A3. And in this way, if we go down, Sn is A1 plus A2 plus so on, An, and second last term is An minus 1, then it is the Sn minus 1 plus An. That gives general formula to find out An. An is S of n minus f of n minus 1. For all, we take n greater than equal to 2, that is a Fibonacci sequence, as S1 is individual, that is A1, which is the formula for An when the sum of series of n term, that is Sn, is given. So by this method we can find the sequence when we have series formation. Now we will do some problems which are based on series. So the first one is, for the sequence An, we have Sn is equal to n cube minus 2n. Find the first 4 terms and 8th term of the sequence. Now here in this we have series and we have to find out the sequence, as we have Sn is equal to n cube minus 2n. So first of all we will find out S1. S1 is 1 minus 2, that is minus 1. Therefore A1 is equal to minus 1, as we learned in the previous lecture. So we will find out S2. S2 is n cube, that is 8 minus 4, that is 4. And we know that A2 is equal to S2 minus S1, that is 4, minus of minus 1, that gives 4 plus 1 is 5. So A2 is 5. Now S3. S3 is 3 cube 27 minus 6, that is 21. So A3 is S2 minus S3 minus S2. S3 is 21 and S2 is 4. So we get 17 as the third term of the sequence. Now the fourth one is S4. S4 is 4 cube, that is 64, minus 4 into 2 is 8, that is 56. So A4 is S4 minus S3, that is 56 minus 21, that is 35. Therefore, four terms of sequence are minus 1, 4, 21 and 56. From this we get minus 1, 5, 17 and 35 are the four terms of the sequence. Now we have to find 8 terms. So therefore 8 term will be A8, that is the S8 minus S7. So S8 is 8 cube minus 16 minus 7 cube, that is 8 cube, not 8 square. So 8 cube is 512 and 7 cube is 343 and 7 twos are 14. So we get 496 minus 329. So the 8th term of the sequence is 167. So this is all about the series from which we get the values of sequence by this method. Now the next problem is, from the formula for the series, Sn is equal to 4 raised to power n minus 1. Obtain the formula for the corresponding sequence. Now here S1 is equal to 4 minus 1, that is 3. That is A1 is equal to 3. Now we have to find An. An is equal to Sn minus Sn minus 1. So Sn is 4 raised to power n minus 1 minus 4 raised to power n minus 1 minus 1. So we get 4 raised to power n minus 1 minus 4 raised to power n minus 1 plus 1. So we get 4 raised to power n minus 4 raised to power n over 4. So we will take out common 4 raised to power n and we get in the bracket 1 minus 1 by 4. So we get 4 raised to power n 4 minus 1 over 4 by taking LCM. So we get 4 raised to power n, that is 3 over 4, and we get 3 into 4 n minus 1. 4n greater than equal to 2. That is a general form. Now we will check if n is equal to 1, then it becomes 3 into 4, n minus 1 is 0, something raised to power 0 is 1, we get 3. Therefore, An is equal to 3 into 4, n minus 1 is all valid for n greater than equal to 1. So this is a general formula for the given sequence.